Number 1, in a survey, a researcher questioned Minecraft, Fortnite, and Roblox players. The number of Minecraft players was, it already sounds like they're setting up an equation. I'm thinking like m equals 6,000% divide by 100 to turn it into a decimal, so 60. Of is times the number of Roblox players, we'll call that R. And the number of Fortnite players, F, surveyed was equals 32% divided by 100 gets us 0.32. The number of Minecraft players times M. They tell us there were 4,608 Fortnite players, so we can plug that in. 4,608 is equal to 0.32 M. If I divide both sides by 0.32, we should get that M is equal to 14,400. And then we can plug that into our other equation as well. If I plug in 14,400 and I set that equal to 60R, divide both sides by 60, we should get, can I fit it here? We can. R is equal to 240. And finally, they say, what is the sum of the number of Minecraft players and Roblox players? Well, Minecraft is 14,400. Roblox is 240. So your final answer should be 14,640 here. Number 2, on a stretch of land, 40% of the area is orchard, and the remaining 60% is meadow. So we can try to draw that down below here. We have a piece of land. We have orchard. We have meadow. And this is going to be 40%, which means this should be about 60%. Next, they tell us that there are buildings on exactly 22.5% of the orchard. So if we try to break this down, remember to divide by 100. So we have 0.225 has buildings, which would mean 1 minus 0.225, or 0.775, doesn't have buildings. They also tell us that buildings on 15.5% of the meadow. So same thing, we can do 0.155 has buildings, which means 1 minus 0.155, or 0.845, does not have buildings. Finally, they say that 30% of the land that is free of buildings, so that's going to be these two. So 30% of this is going to be something. Both in the orchard and the meadow contains a particular species of flowers. So we can calculate that right now. We want to be careful here, so we need to start all the way back at 40% of our land is meadow, or is orchard, and then times 0.775 because that's what doesn't have buildings, and then times 0.3 because that's the part of the non-building land in the orchard that has flowers. So if we do that, 0.4 times 0.775 times 0.3, I'm getting, where can I fit this? 0.093 for that side. And for the left side, I'm getting 0.6 times 0.845 times 0.3. So that's going to be 0.6 times 0.845 times 0.3. I'm getting 0.1521. And if I just add that to 0.093, my final answer here, I'll write it up above, is, and this is a trick, it's not 24, it's not 0.2451. They want it Q%. They want it back into percentage form. So my final answer here is actually going to be 24.51%, but you would just enter that. Number 3, I see a function up above in factored form. They say m is a constant, that it's a parabola, and the x-coordinate of our vertex is 151. And here's where you want to remember all your little tricks. Factored form tells us our two x-intercepts. My two x-intercepts are negative 17, because that'll get us to 0 for the y. And then negative m would also get us 0 for the y. Remember that your two x-intercepts are going to be symmetrical around your vertex. Therefore, if I add my two x-intercepts together and divide by 2, that should get me my middle, my vertex. So if I do negative 17 plus negative m divided by 2, this should be equal to 151 times both sides by 2. I get negative 17 minus m is equal to 302. Add the 17 to the other side, we get negative m is equal to 319, or finally that m is equal to negative 319, by far the fastest way you can do it. Make sure to remember all those little tricks. Number 4, I see a function up above. More importantly, I see something distinct about this function, and that is I see common factors in two parts of my equation. So this is a College Board classic for more advanced problems, of course. So if I can get both of these to the same side, I can factor out that x plus 5, and it's gonna make it much easier for us. So down below, we have 3 times x minus b still. That's times x plus 5. And then I subtracted over the 2 times x plus 5, and now everything's equal to 0. And now that they're both on the same side, we can factor it out. So this is going to look a little weird, but we're going to try to make it make sense. I'm factoring x plus 5 out of both terms. So this will be term 1. This will be term 2. So what's left from term 1 is going to be 3 times x minus b, because if I would redistribute it, I would get back to where I started, right? And then minus term 2, that's just going to be a minus 2 because we factored out the x plus 5. So think about it. If I just distribute this back into my 2, I'm going to get what was up above. That should be equal to 0. And then all I have to do is I want to simplify my right parentheses here. So my left one's still x plus 5. My right one's going to be 3x. I'm just distributing. 3x minus 3b. And then minus 2. And then what we can do now is, since both of these are equal to 0, we can get both of our solutions, both of our intercepts here. So I can say, well, when x is negative 5, we get 0 here. This one's going to be 3x is equal to 3b plus 2. I just added them both to the other side. So our x over here is going to be b plus 2 over 3. Now finally, back to the problem. They wanted the sum of our solutions. So that was the whole point of this. We got our two solutions right here, negative 5 and this. So if we add both of these together, negative 5 plus b plus 2/3, this should be equal to the sum of our solutions, 23 over 3. So to make this easy, we could just multiply everything by 3. So we would have negative 15 plus 3b plus 2 is equal to 23. And I don't have much room left, but we'll try. I would add 15 to the other side, so we have 38. But then I would subtract 2, so we have 36, is equal to 3b, or finally, b is equal to 12. And that's all you got to do for that one. Number 5, in a set of 4 consecutive even integers, where the integers are ordered from least to greatest, the first integer is represented by a. So let's pause there and think about that. So we know our first integer is a, and we can always compare it to real numbers. Let's say we're starting at 2. Consecutive, so next to each other, even integers. So it's not going from like 2 to 3, it's going from 2 to 4 because it's your next even number. Well, if a is 2, well then 4 would be a plus 2, it's 2 more. And then my next even number would be 6. So to go from 2 to 6, it would be like going from a plus 4. And finally, my last one would be 8. So from 2 to 8, we need to add 6. So it'd be a plus 6. So it seems like those are the 4 integers that they want us to have. They say the sum of the second and third integers, so the sum of this and this, is at least. So I said we pause there. We should have a plus 2 and a plus 4 on the left side. So already I'm thinking we can get rid of these two because a and b are matching so far. They say is at least. So let's think about that part too. If you have at least $100, you have 100 or more. So we can actually already answer it just from that. We want the greater than because it's at least. So it's already a. But just for practice, let's make sure the right side also makes sense. Is at least 19 less. I know that's very weird wording. When they say 19 less, it sounds like you're supposed to start with 19. They're actually saying subtract 19. It's 19 less than 100. That would be 100 minus 19. And finally, the sum of the first and fourth, that would be a and a plus 6. I see a plus 6, I see minus 19. It is 100% a here. Number 6, I see a linear equation up above. They tell us that s estimates the distance a spacecraft has traveled in kilometers from its launch pad in Texas, X hours after exiting Earth's atmosphere. What is the best interpretation of 18 in this context? So a couple things to note here. To analyze our y-intercept, we always want to consider when our x is 0. And what that would tell us is at 0 hours after exiting Earth's atmosphere. That means you're right at the border. You're practically at the edge of the atmosphere. We have traveled 18 kilometers from the launch pad. So what that's telling us is from launch pad to border of the atmosphere before we've exited the atmosphere, we've already traveled 18 kilometers. That's going to be really beneficial for us in the next couple questions. So in A, after exiting Earth's atmosphere, the spacecraft traveled an estimated total distance of 18 kilometers. Well, we like the units. We do want 18 in kilometers. But have we exited the atmosphere yet? When we are at our y-intercept, that means our x is 0. X is supposed to represent the hours after exiting the atmosphere. So if we're at 0, we haven't exited the atmosphere yet. So while A does sound tricky, this 18 isn't beyond the atmosphere. This 18 is from our launch pad to the edge of the atmosphere. So it's not going to be A here. In B and C, these are kind of like our easy, not right answers. Our units, our y-intercept is always going to be in the units of our y, which is kilometers, not kilometers per hour. So we can get rid of both of those. And then finally in D, between the launch pad and the atmosphere, that is going to represent 18 kilometers because when x is 0, we haven't left the atmosphere yet. It's going to be D here. Number 7, a marine biologist monitored reefs in an area. Each year, the biologist recorded the number of fish observed at each of the first 60 reefs that were surveyed and created a frequency table for the dataset. Which of the following frequency tables represents the data with the smallest standard deviation? So this is pretty standard. On the left are the actual data values. So they're saying there was 30 fish 0 times, 31 fish 6 times, 32 fish 48 times, right? So what we would actually picture is like 31 6 times, 32 48 times, etc., right? On top of that, this is our standard deviation. Remember, with standard deviation, you don't actually have to calculate anything. It's all visual. All we need for low standard deviation is you want it concentrated in the center. You want all of your data centered with like very little deviation from that center, from your mean, right? So already in A, we see 48 of our data values are directly in the middle at 32. To the left of that, there's only 6 31s, and to the right of that is only 6 33s. This is really low standard deviation, really centered data. So far, we're already really liking A. In B, it does still kind of have a center. Notice how 24 of our values are at the center, and then we spread out 12, and then we spread out another 6, spread out 12, spread out another 6. So there's a little bit of a center here, but you can tell it's way more spread out. Half of the values are in the center as compared to A. So this is going to be higher than A. In C, again, it's similar to B where, yes, some of our data is centered. It's still less than A, and it's still more spread out than A. We have 15 2 units away and 15 another 2 units away. This is going to be higher than A. And finally, in D, honestly, probably our worst data, we have no center. We have 12 values at all 5 data, or 12 frequencies at all 5 values. This is the most spread out value. This is going to be our highest standard deviation. It's just going to be A here. Number 8, a teacher compared 2 groups of students, group A and B, who used different study methods for an upcoming exam. The list shows the scores earned by each student in the 2 groups. Here's my 2 data sets. Which statement correctly compares the median test score for group A and the one from group B? So with medians, I feel like usually they give you the total number of values here, but we can count it up pretty quickly. So we have 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. So we have 13 in group A. So we can do our little median trick. This is even more helpful when there's more numbers than this. So that is, take your median when it's odd. So that's your middle number. There's 12 values left. So that's 6 to the left and 6 to the right. That's 13 total values. And finally, your median would be your 7th value. So 1, 2, 3, 4, 5, 6, 7. We know that it's 89 in group A. It's a little bit more awkward when there's even numbers. Let's just double check. 1, 2, 3, 4, 9, 10, 11, 12. So there's 12 in group B. Of course, they make it a little bit more difficult. When there's an even amount, let's just go over to the right again here. So we have 12. You take your middle 2, and that's going to be 10 values left. That's 5 to the left and 5 to the right. So what that means is I want my 6th and my 7th value, and then you're going to have to find the average of those two. So 1, 2, 3, 4, 5, 6, and 7. And we can just take the average of these. If I add up 85 plus 93 and then divide by 2 to get my average, I get the same thing. I get 89 for the median of group B. So finally, our answers are probably like one's bigger, one's smaller, maybe one's not enough info, and then they're equal. So in A, I see right off the bat, the median of A is equal to B. Just to double check, greater, less than, and there's not enough info. Yeah, so it's just going to be A here. Number 9. The table summarizes the distribution of age and kennel group for 120 animals in a shelter. On the left, I see the 3 groups, and up top, we have the age range of the animals. Down below, they're going to be selecting one at random. What is the probability of selecting an animal from group X, okay, given that the animal is at least 10 months old? So remember with givens, it does change our parameters a little bit. They're telling us up front that from the random group we're choosing from, we know that they're 10 months or older. So what you can do is you can actually just get rid of this entire column because we know they're 10 months or older, right? And they want the chances of group X. So with probability, you always want to remember it's what they want divided by your total. They've already told us our total. They told us that all we know is the animal is 10 months or older. So that means it can be from these 40 or it can be from these 40. Since it's 10 months or older, it can't be from this 40. So I do know my denominator is 80. And then for our numerator, it's what they want. They want it to be from group X. So for it to be 10 months or older from group X, I see 12 and 10. So my numerator should be 22. Of course, we don't want non-reduced fractions. So you could type this in as a decimal, or you could type in 11 over 40, and you should get the right answer. Number 10. Right rectangular prism M is similar to right rectangular prism N. The surface area of M, the surface area of N, and they give us the volume of N. So this is going to be another College Board classic with a very specific rule set. So you know to use this format if you ever have two similar three-dimensional objects and they're doing some sort of comparison of surface areas, volumes, lengths, etc. So down below, we're going to map this out. We have two objects, N and M, and they specifically are comparing surface area, but it's important to outline the length comparison and the volume comparison as well. And then in the middle, we're going to do like two little multipliers. Maybe I'll just call it Y and Y, and you're going to see why. Let's fill in a couple of the blanks. They do tell us the surface area of M is 64. That's kind of dark. Let's do this one. So they tell us this is 64. They tell us the surface area of N is 1600. And then here's where the magic starts. These two columns I have here, there is a defined relationship between two similar three-dimensional objects. For surface area, it's going to be y squared. So there's some value squared that times our 64 gets us to 1600. For length, it's just y. And for volume, it's y to the third. So let's kind of just figure it out, and then you'll kind of see what I mean. So 64 times some value squared will always get me to the surface area of the other object if they are similar. So I would just do 1600 divided by 64, and that gets me 25. So that would mean if y squared is 25, my y is equal to 5. So we actually just defined all of our multiplying factors. That would mean their lengths are by a factor of 5. Their surface areas are by a factor of 5 squared, and their volumes are by a factor of 5 to the third. So in these problems, they're always going to give you a third entry, which helps you fill the rest of them in, and that is that our volume for N is 7,500. So finally, we could just do, we'll call this maybe like A. So A times this 5 to the third is going to get me to 7,500. So all I have to do is 7,500 divided by 5 to the third, which is 125. And that tells me that my M, and let's try to use a different color, My M volume is going to be 60 here. But finally, they don't just ask for 60. They want the sum of the volumes of M and N. So your final answer is just going to be 75, 60.